Hello, welcome once more. Let's look at this question on calculus, integration, and then differentiation. Okay. If f of s is equal to 2sk plus 3s squared plus ps plus q is such that integral of 2 f of s, which we have the limit 2, 0, dx is equal to 6, and integral of f of s with the limit 1, negative 1, dx is equal to negative 2. Then find the values of p and q, and then the value of the first derivative, f prime of negative 2. That is the first derivative of the function. Alright. So now let's go to the a quickly, and then move to b, and let's see how we are going to solve our question. So we're given what? We're given f of x to be equal to 2s cubed plus 3s squared plus px plus q. And they say this is such that the integral of this function, okay, with limit 2, 0, will be equal to 6. So the integral of the function f of s, what is the f of s? 2s cubed plus 3s squared plus px plus q dx will give me what? Positive 6. So what we mean that we are going to integrate this with the limit 2, 0, and then after doing that it will be equal to 6. Okay, so how do we integrate this? We'll add 1 to the power of the x, and the results we get, we divide. Alright. So we are going to get, we have 2x, 3 plus 1 give us 4, all divided by 4, plus, we have 3x cubed over 3, plus 2s squared also over 2, plus qx over 1, which is the same thing. Okay, with the limit 2, 0 to be equal to what? To be equal to 6. So when I'm giving the limit like this, well, this one can be written as 2 over 4 will give me 1 over 2 s exponent 4 plus 3 over 3 is 1, so s cubed plus this is over 2, so I can say 1 over 2 ps squared plus what? qx. Okay, it's our limit 2, 0 equal to 6. Okay, so I've simplified this. We have this. So if you have this, then this is what we are going to do. You do substitution. You substitute the value of 2 to wherever you see the variable x minus, then we substitute the value 0 to wherever we see the variable x into the same integral function. So we are going to have 1 over 2 exponent 4 plus 1 over 2, okay, 2 exponent 3 plus 1 over 2p, 2 exponent what? 2, alright, plus q, also multiplying 2. So we have substituted 2 to wherever we see x, minus, we also have 1 over 2, alright, then we substitute 0, 0 exponent 4 plus 0 exponent 3 plus 1 over 2p, 0 squared plus q, also multiplying 0. Okay, so this is what we have. Alright, then we know that 2 exponent 4 will give us 16, and half of 16 is going to be what? 16 times 1 over 2 will give us 8. So here 8 plus 2 exponent 3 will give us 8. And then here too, we have 2 exponent 2 to be 4. Half of 4 is 2, so we have 2p. 1 over 2, 2p, plus then 2q. So we have this minus, alright, so here will give us 0. 0 times will give us, this is 0, 0 times will give us 0, and this is 0. So minus 0. So this is equal to 6. So let me bring that equal to 6. Alright. So that we have 2p plus 2q to be equal to, so 2p plus 2q will bring it to be equal to minus 16. Alright. Minus 16, sorry. There is 6 here already, so 6 minus 16. So 8 plus 8 here will give us 16. So when you take the 16 here, it will be minus 16. So 6 minus 16, this is 0, 2p. So what are we going to have here? We have our 2p plus 2q to be equal to 6 minus 16 will be negative 10. So we have 2p plus 2q to be equal to negative 10. We can reduce this. So they have p plus q to be equal to a negative 5 by dividing through by 2, 2, 2. So you have equation 1. So we are done with the first one. Let's go to the second one. All right. So I hope our board becomes enough for us. So when we go to the second one, we also have what? Integral of 1 negative 1 f of s. What is f of s? 2s cubed plus 3s squared plus px plus q to be equal to dx to be equal to negative 2. Alright, so we have this. So in the same function, we are integrating so that we can say, since we have already done it here, let me write this one there, because when you integrate this, this is the same to have 1 over 2 x exponent 4 plus s exponent 3 plus 1 over 2 ps squared plus qx. The limit is 1 negative 1 equal to negative 2. Okay, so this is what we have. Our limit is 1 equal. So we are going to do the same thing. Substitute 1 minus the substitution of negative 1 into the same function. All right, so we have 1 over 2, 1 exponent 4 plus 1 exponent 3 plus 1 over 2p, 1 exponent 2 plus q multiplying 1. Okay, so we are done with the substitution minus, we also substitute negative 1. So 1 over 2 minus 1 exponent 4 plus minus 1 exponent 3, all right, plus 1 over 2 p, s is minus 1 squared plus q minus 1. Okay, so we have also been able to substitute minus 1. So what we are going to do now is what? Is to do the multiplication, remove the bracket, and then move on. Equal to negative 2. So let's not forget that the whole of this thing is equal to negative 2. All right. So now let's see. 1 exponent 4 is 1. So times half will give me 1 over 2 plus 1. 1 cube is 1 plus 1 square is 1 times half p, give me half p plus q. Okay, so we have this minus, we also have minus 1 exponent 4 is 1 times 1 over 2 will give me 1 over 2, and then minus 4 exponent 3 is negative 1, so minus 1, and then minus 1 exponent 2 is positive 1 times has to plus 1 over 2p, and then minus 1 times q minus q, and that will be equal to negative 2. Okay, so this is what we have here. So now we are going to simplify and see so that we can get our answer. We have 1 over 2 plus 1. I think that will give us 3 over 2 plus 1 over 2p plus q minus 1 over 2 minus 1 is minus 1 over 2. Alright, so 1 minus 1 over 2 give us plus 1 over 2. And then this one give us minus times 1 over 2p minus 1 over 2p. Then minus 1 will give us plus what? Q equal to negative 2. Okay, so this is what we are getting. Alright. This is what we are getting. So realize that we will have positive 1 over 2 here, which will take off the negative 1 over 2. Alright, and then what do we have again? We also have Q plus Q, and that will give us what? Q plus Q will give us 2Q equal to, I think only Q is left, right? Q plus Q. And then we have minus 2. Then let's take the 3 over 2 here to be minus 3 over 2. And then there is 1 over 2 here, so let's also take to be minus 1 over 2. Okay, so we have 2Q to be equal to minus 2 minus 3 over 2, and then minus 1 over 2. So with this, let me use the calculator so that we can quickly go by this and we see the answer. So minus 2 minus 3 on 2 minus 1 on 2 will give us negative 4. So that we have negative 4 here. Okay, so our 2Q is equal to negative 4. Alright, so that what happens is, for 2K is equal to negative 4, then we can say that it implies that our Q is going to be negative 4 over 2, and that will give us negative 2. So our Q is negative 2. Then we have to come and find our P. Well, the question is, we find the value of P and Q, our P. So we substitute the value of Q into equation 1. So from equation 1, then what we can say that P plus Q is negative 2, so minus 2 equal to minus 5. Alright. And our P is going to be minus 5 plus 2, and that will give us negative 3. So our P is minus 5 plus 2, which is minus 3. Therefore, let's conclude here. P is equal to negative 3, and Q is equal to what? Negative 2. So our P is negative 3, and our Q is negative 2. I believe you got it. Alright. So now let's quickly go and solve the B, the value of f prime of negative 2. Then first, so I believe you got this. I'm going to clear it. Look at how lengthy it is to get our answer. So interesting. Math is so interesting and beautiful. So let me clear it, and then let me clear this side. I think our so that we solve for the, I think it will go here. Okay, here is okay. So now let's solve the B. So the B is saying that we should find the value of f prime of negative 2. And we know that f prime of negative 2. So first of all, we find the f prime of x. Then what we do is to what? We substitute negative 2 into the function. Alright. So what is our f prime of x? Our f prime of x is the same as dy over dx. Okay? That is the first derivative of the x. So what is our function s? Our function s is here. So if I want to find the f prime of x, then that will be already our, okay, f prime of s will be equal to, our f of s is here. So what we do is that we multiply the 3 by this 2 and we subtract 1 from here. That is differentiation. So 3 to give us a 6 minus 1. So 6s squared plus 2, 3, 6, 2 minus 1, 1. And then plus, okay, before that, I think we have to do substitution. We have to substitute the values of the P and the Q into the function so that we can solve. Yes, we have to do substitution before. So now let's do a substitution. What do we get so that we can write our f of s is now equal to 2s cubed plus 3s squared plus, what is the P? What did we get for P? P is negative 3, so minus 3x, and then what is Q? Q is negative 2, so minus 2. So this is what we have for our function. Alright, so 2s cubed plus 3s squared minus 3x, because P is negative 3 and then Q is negative 2. Therefore, our f prime of x will be equal to 6s squared, then plus this one multiplied to 6, and we subtract 1 from the 2, so 6s minus 3. Alright, so we have this. Okay, so we have 6s squared plus 6s minus 3. The constant will give us 0 when you differentiate. So you take the exponent here, you multiply by the constant here, you subtract 1 from it. So 3, 2, 6. 3 minus 1 is 2. 2, 3, 6. Minus 1 is 1. And then here is 1. 1 times is negative 3. 1 minus 1 is 0. So s exponent 0 is 1. So 3 times negative 1 is negative 3 times 1 is negative 3. And then here too, the constant will become 0. Okay, so now let's do our f prime of negative 2. We substitute. So 6 times negative 2 squared plus 6 times negative 2 minus 3. Okay, so negative 2 squared is going to give us what? Positive 4. 4 times 6 will give us 24. And then 6 times negative will give you minus 12 minus 3. Okay, so 24 minus 12 will give us 12. 12 minus 3 will give us 9. Therefore, our value of f prime of s is equal to 9. I believe you understood it. Okay, so what I'll urge you is that if you want more, then subscribe to our YouTube channel, Best Grade Mathematics Class. Share this, comment. You can also find on Facebook, Best Grade Mathematics Online Class. And then you'll be blessed. See you once again. Bye-bye.